So question 4 is kind of small, so I don't really know if I can see this. So this is I have a C triple bond N here plus MgBr. So this is a Grignard reaction. So I have a benzene group basically MgBr, and then basically over ether, and then H2O, what am I going to get? And then finally, if I add an acid workup, what am I going to get here? So basically, this reaction here is kind of a Grignard reaction, right? I have kind of a this here makes it a positive carbon here. I have a positive carbon basically on, like, this carbon is very positive because the bromine is basically makes it a positive carbon here. It's a nice Grignard reaction here, and I have again this double bond here is a very electron rich with this nitrogen here. So simply this is going to attack here, and then get rid of this bromine. So I would get something like this. Get C, and then I would have like triple bond and bond, and then a benzene group like so. So I get something like this, and then finally over acid and heat here, or is this? Oh, this is with the acid workup. Yeah, so that's fine. And then with I'm adding acid and water as well and heat, I would get this would be able to I would basically kind of eliminate something, right? So let's see. If I have a benzene group here and I have a triple bond here, I don't know if elimination is going to happen here. So let me just see what they wrote here. So I have yes. So this here is correct here. I have this here is correct. This triple bond here is bonded to this benzene. The benzene here. And it's going to eliminate here. So I have actually a double bond. So this here, so yes, this here is actually a correct one here, because this I forgot that we also I had water here. So that's my sorry, an acid here. That's my fault. This here is H3O plus. H3O plus, and this guy here is I would have a double bond here, right? So I have the carbon like so. This guy would be a double bond instead, and I would basically link to this to the triple bond here. So this arrow is actually incorrect here. This arrow is not good. It's basically the triple bond that's coming to attack here as well. So this here it would make it a double bond, basically a double bond N here. And then this guy would be linked to my benzene group here. That's good. So I have that one here. So sorry about I didn't clarify the arrows here. That's my fault here. And then finally I have H3O plus and H2O in heat. And what that's going to do is it's not going to affect basically the benzene group here, but it's going to change this double bond and here, right? Because I have, again, lone pairs on this side here. I have lone pairs here. So basically what's going to happen is that these lone pairs are going to take a hydrogen from the acid. So I'm going to get something like this. See, I have double bond N, bond H here. It's probably going to take actually two hydrogens. So this step is going to actually happen twice here to get NH2, and this here would become a positive charge, makes this nitrogen a positive charge here, and then I would have a benzene like so, and then basically this makes it a good leaving group for this OH to come and attack it, right? This OH here has a negative kind of dipole here. This one can go like so and actually kick this entire thing out, and we get basically this compound here, bond OH, and then the benzene like so. And then finally what you can do with this one, it can actually oxidize and form the ketone here. So this guy can oxidize and form a ketone, like so. So this here, again, this is just an oxidation reaction, right? Or you can say, I can basically say that it's adding, it's actually just simply adding the double bond. So I don't think it's even adding the OH here. It's adding the double bond directly here to get this guy here. Because again, I do have an acid and I do have water to give me my protons here. So this here, solution here is correct. Great solution, but they didn't really provide an analysis, but no analysis provided. It's simply a Grignard reaction reaction to form basically the carbon bond. So actually to link benzene with the I guess this would be with the first group. So this would be a C double bond, and you can say it's with the alkyl group. I'll just say alkyl group, and then acid workup to I won't say acid workup actually. I'll say actually it's acid workup to get rid of to make nitrogen a good leaving group for water to substitute it. So the solution here is correct. Great solution.